Welcome. Here we'll take a look at some distribution shapes, some of which we've seen already. Let's start with our first one, the shape of that distribution. We saw this with the Chester's churros example. That is our bell-shaped distribution. So that distribution is called bell-shaped. And we'll also learn in a future chapter that that shape comes from distributions that are called normal. So a normal distribution has a graph that is bell-shaped. So to create the bell-shaped distribution, most of the data points would be towards the middle of the possible range, and it would taper off symmetrically to the left and to the right of that center peak. So because there's just one peak in the graph in the center, that distribution is called uni for one, and modal, so one place where most of the data lies, that peak at the center. Now, bell-shaped curves are symmetric, but not all symmetric distributions have to be bell-shaped. So we'll see another example of a symmetric distribution in a moment. So let's come over to this distribution. So now we've got a graph where across this range of values, the heights, which would be our frequencies or relative frequencies, are approximately the same. So we would call that distribution uniform. All right, our next shape. So as opposed to our unimodal graph, a graph can have two distinct peaks. Notice the peaks don't have to be at the exact same height. We're just saying at a point in the graph, we've got a peak near that bar. And that bar also creates a peak if we look near that bar. So two distinct peaks, and that would be called bimodal. So two modes, two modal locations. All right, and now I've got another graph here that is also symmetric, but it is certainly not a bell shape. It is called a U-shaped distribution because it looks similar to the letter U. So U-shaped. And then a couple more, and each of these we have seen in chapter 2 already. So are distributions that are not symmetric, but they are skewed. So this shape where we've got more of the data on this low end of the range, and then it tapers off as we go to the right, is called skewed right. And another name for that would be positively skewed, so skewed in the positive direction. So I prefer skewed right, but either one perfectly acceptable. And then sort of the opposite of that, more of the data here at the high end of the range, but then it tapers off as we go to the left. So that's our skewed left, and that is also referred to as negatively skewed, so skewed in the negative direction. And then I just gave a couple examples of each of these. So an example of a positively skewed graph would be earthquake magnitudes. So fortunately, most earthquakes are on the low end of the magnitude range, and fewer earthquakes as we have these higher magnitudes. And then my skewed left example, age of retirement. So most people would retire in their older years, and there would be younger people retiring, but not as many of them. So there are many more shapes out there. These are just a few, and we will typically be working a lot with our first example. So as we move further into the course, we'll spend the majority of our time really talking about these bell-shaped distributions.